I personally do really love my job. I truly do. I basically am the responsible person to look after the data center market. And I do it globally. So I do have the opportunity and the possibility to basically speak to all sorts of operators which are existing in a scenario. You name it. You can have a co-location, you can have a telecom operator, you can have an edge operator, you can have an hyperscaler. But I do also have the possibility to speak around the globe with different customers and different actors. I do have the possibility to speak in Asia. I do have the possibility to speak throughout EMEA. I do have the possibility to speak with clients from the United States. And I have to say that despite we're talking about IT equipment protection, the data center ecosystem from a supply chain standpoint is still a jungle. And it's very, very simple. I mean, if you talk with the different operators, you may have different nuances depending on their region, different nuances depending on their cluster, different nuances depending on the specific characteristics, requirements that they might have. So the responsibility of us as supply chain industry is basically finding out models to be able to support all these industries across the globe in the most efficient way. And I do have the possibility to look after the data center business, which is probably representing the fastest growing industry over the last decade. And in fact, we have seen what happened over the last maybe 10, 15 years, right? So we started 15 years back with IT rooms or with some kind of enterprise data center. And then basically there was the telecom appearing, there were the hyperscaler, all of a sudden crashing the party, coming in, changing the game, changing completely the paradigm of the business. And then additionally, we had the co-location operators, a brilliant model. And finally, nowadays, we're talking about edge, and surprise, we're talking about artificial intelligence revolution. So what has happened over the last 10 years in the data center industry is just a mind-blowing exercise. And we have a lot of different consequences of this acceleration. So we may have, for example, not only an explosion of the ecosystem itself, but we have different architectures also for a simple reason. There is not a single solution that fits everyone, that fits every single need. So we have different power architectures, different system architectures, and also we have another characteristic which is very, very important. We have seen an increase of the power demand. So back in the days, we used to speak about data centers which were in the range of about probably 1 megawatt, 2 megawatt, 3 megawatts. We even had the 5 megawatt scale. But today, I mean, it's very, very simple to talk about data centers with scope of supply of 20, 30 megawatts, in some cases 50 megawatts. In some instances in Europe, we start seeing campuses of 250, 300 megawatts per operator. And of course, I mean, when you start having so much power required, immediately the data center operators will become the evil of the world. For a simple reason, they require a lot of power, they require a lot of water, and they will require a strong point of connection to a stable grid. And the ultimate question is, where do I get the power from? Where do I get all this water from, right? So immediately, there will be a lot of discussions at the level of government and at the level of the utilities looking at the data center operator not anymore as an opportunity, as an evolution for the future, but as a threat. So it's very, very interesting what is happening in the industry, and I have to say that, I mean, these are basically the major scales and the major trends in the industry, but on the other side, we have to say that there are a lot of different situations which are also impacting the evolution of the ecosystem, and we have seen it. Sustainability today is probably by far the most important parameter. It's probably the most important, let me call it, the most discussion topic that we have nowadays in all industries, across all industries. But since the data center industries are becoming very power hungry, then the sustainability topic is for sure on the top of the agenda of all the data center operators. And in fact, all of them, they have initiatives to reach the so-called net zero programs. Now, We also recall a few years back there was the COP19. 150 countries gathering together, trying to sign up some protocols to reduce the globe temperature by 2 degrees, which means by reducing the carbon footprint by 20% or a 40% quota by 2030. 2030 is very, very close, by the way. So, this is a very, very challenging target. And on top of it, we also have to consider that over the last 3 to 4 years, we have seen a huge inflation popping up. We have seen a huge amount of difficulties from a supply chain management standpoint. And last, we have seen an increase of the global geopolitical instability. And what is the consequence of all of that? It's very simple. The cost of the kilowatt hour of the electrical energy has been more than doubling over the last 3 to 4 years. And so the key question that we have been trying to address at Riello UPS is how can we help the data center operator, the data center industry, the data center ecosystem to become more sustainable and at the same time to reduce the energy bill cost. Good morning, everyone. My name is Antonio. As said, I'm basically running after the data center business at Riello UPS globally, and I'm very, very happy and delighted to be with you here today. So basically what we're trying to do is providing you a little bit of an indication of what we have been doing over the last 3 to 4 years at Riello UPS to target the data center industry and at the same time to resolve all the problems of the data center industry and all the problems related to the sustainability trends. And the starting point for our consideration, it has been, I can tell you, it has been a 3 years program, probably 4 years program, and it has been a painful program because we have been having a lot of successes, a lot of ups and downs, but finally we made it right because the assumptions were actually right. Because we started from the consideration, okay, let's evaluate what is the total cost of ownership. And if you take a data center operator which is already in running condition, you can get that 60% of the cost of the data center is represented by the electrical energy bill. So it's actually clear that under this constellation and this situation, in order to get to the point of the question mark that we addressed before, in order to support the data center industry, we need to provide UPS equipment which is highly efficient and also which is enabling at the same time to reduce the carbon footprint within the data center space. And so we have been doing also some kind of analysis, right? You have to consider one thing. Today, pretty much all the data centers are running under UPS. All the electrical, all the IT rooms are basically running under UPSs. And if you have a data center campus which is ultimately 1 gigawatt, because there are trends in this direction, you may end up with 1,001 megawatt UPSs in a single campus. The entire electrical energy is going to be processed by the UPS. And if you take the legacy UPSs, these are double conversion machines, which are processing the electrical energy with an efficiency which is in the range of 96 and 96.5% if the equation and the mathematics and the physics are getting cleared, okay? So we have been starting from the consideration, what happens in this industry if instead of a 96% double conversion UPS, you would implement a 97? And we have done a calculation which is based on two different parameters. We have considered an equivalent cost of the kilowatt hour of about 10 euro cents per kilowatt hour. And also we have considered what is the ultimate trend in Europe, 30 euro cents per kilowatt hour. My apologies, I speak Euro, and I can tell you that if I look at the cost of the electrical kilowatt hour here in India, we are very, very close to this parameter here. Okay? So if you have just UPS 1% better in efficiency on year one, if you take a 1 megawatt installation running at 50%, you can already save 5,000 euros of running energy cost. But if you take, for example, the European case, with 1 single point% in terms of double conversion efficiency, the savings that can go actually to 15,000 euros per UPS, per machine. But then we said, okay, we joined the party, but we want to be much better. And we have been thinking, what would happen if we had a 98 double conversion efficiency instead of in 96. And surprise, surprise, the equation, it's of course, very linear. If you take, for example, the calculation done at 10 euro cents per kilowatt hour, you start immediately seeing savings up to 10 kilo euros per unit. But if you start doing the mathematics for the European case, then you can immediately find out that the saving per 1 megawatt UPS, they can go up to 30,000 euros if the UPS is constantly running at its optimization point. So this is a lot of money. And the key question mark is, okay, so we have done a simulation. Can we go from the simulation to reality? Again, ladies and gentlemen, I have, again, the honor and the pleasure. I'm the lucky guy in the company. I have the pleasure to introduce you a new family of double conversion UPS, which has been aiming to 3 fundamental pillars: energy efficiency, vertical and horizontal scalability for fast deployment, and third, monitoring, advanced monitoring to go towards what we call autonomous operation of the unit. This is a full family that goes from a 500 kilowatt up to 1.6 megawatt per block. And it's fully modular, and it's actually realized with this power module, which has an engine of about 67 kilowatt in double conversion. This module here, certified, is achieving a stunning energy efficiency in double conversion mode, which is 98.3%. And when it comes to system level, integrated into the system level, we are exceeding 98% in the overall operating range between 25% operations and 50% operating load. And I can tell you, now we have addressed the why dimension, why we do things. We want to solve the problems of the data center industry. We have introduced you the what dimension, so what we have been doing by what type of products we have been introducing, but I would like to go one further level down. I would like to provide you an indication on how we got it, because as I said, that was an interesting journey for us. And if you look at the power conversion technologies available in the legacy UPSs, you saw that probably back in 2010 or 2012 with the so-called back-to-back two-level conversion technologies, which were achieving a 96% double conversion efficiency. And then, of course, there were a lot of technology trends over the years, moving from a two-level technology going towards a three-level technology back-to-back, you could achieve a 96.5. Doing further optimization on the so-called filter levels, you could even achieve a 97%. But then, in order to reach that dream that we had, to reach about 98% efficiency in double conversion mode, that was not enough. What we did a complete shift in our industry. We started looking at what automotive was doing instead of the traditional UPS industry. And we have been implementing in our technology components which are very highly sophisticated, used in the electrical vehicle industry, and surprise, surprise, these devices are designed to accelerate, are designed to decelerate. They are designed for the highest low profiles that you can find in reality. They are designed for shock. They are designed for vibration. They are designed for water. They are designed for high temperature. They are designed for long life. And surprise, surprise, how is the artificial intelligence loads data centers running? It's a lot of bang, bang between 100% loading and 0% loading, and it's a continue hammering on the semiconductor. Bingo. And another thing which is very, very important, if you take, for example, the standard traditional IGBT technology compared to the device that we have been using, at 100% of the operating point, we could achieve a 60% reduction of the losses of the semiconductor. But in the data center world, most of the time, the operation of the device is between 25 and 75%, because you may have a tier 3, a tier 4, you may have a shared redundant, and so on. So what happens in this range? The losses of the semiconductors go down 80%. Good. If we get this kind of device within our installations, we get an incredible energy efficiency curve that in any point that goes from above 20% loading up to 50% loading, we are always constantly exceeding 98%. If you take the full range from a 10% loading up to an 80% loading, we are constantly exceeding 97.5%. And I can tell you, this is not what we just wanted to achieve energy efficiency. You probably recall the concept, the three-pillar concept. So energy efficiency, scalability, vertical and horizontal scalability for fast deployments, thanks to the modularity approach. But we wanted to achieve also advanced monitoring. Every single capacitor, every single filter installed in our UPSs is monitored through thermocouples. Real time, we know exactly what is the status of health of every single critical component which is characterizing the architecture of our power UPSs. This is how the system looks like. You immediately have an indication of the so-called vertical scalability. This is a 536 kilowatt tower. We basically pretty much have up to 8 modules stacked vertically within the same unit and of course connected in parallel. This is a 1,250 kilowatt unit with 2 different power towers connected, of course, through a system which is represented by the backbone of the overhead rail, of the overhead bus rail, and of course, I mean, with a central I/O unit. And additionally, you may see here, in this area, you may see 3 different top connection boxes with all the connectivity, which is not only redundant, this is redundant per tower. So at the end of the day, you will have a huge amount of redundancy available as well on communication. It's not only about electrical energy efficiency. I'm the electrical guy, I'm not the cooling guy. However, I can do a little bit of mathematics, and I can tell you that if you start having a UPS which is running at 98% conversion efficiency, you don't not only have reduction of the electrical energy cost for the UPS itself, but you have immediately a reduction of the losses of the UPS in the UPS room. And what happens? Your cry unit, your cooling unit, your entire cooling system has to be designed for much less. 2 other consequences: reduced capital investment for the cooling equipment, and also reduce the electrical energy bill to run the cooling system. If you take, for example, one of our UPSs at 1 megawatt, at 100% load, which is basically your design point, at 100% load, we basically have a requirement which is roughly 25-26 kilowatt of losses. The majority of the competition today, if you want to cool down a 1 megawatt UPS running at 100%, you need at least 50 kilowatt of cooling capacity within the electrical room. Thank you very much, ladies and gentlemen. It has been a great pleasure for me here to be here with you. And it's always very, very big honor for me to bring around the globe the true 360 degrees made in Italy concept. Thank you very much, everyone. In case you would like to have certain clarifications on the product, you're more than welcome to come up at our stand. Thank you.